In this video, I will briefly explain the login intent pattern, and then show a demo of an implementation of this pattern using the Curity Identity Server. Login intent is an architectural pattern which enables securely obtaining consents from users. It gives companies a high level of certainty about the user's consent and good accountability. Its implementation is required by some open banking regulations, for example, Open Banking Brazil. Implementation of the pattern can differ slightly, as the relevant specifications and regulations leave some open points. In this video, I will describe and show a demo of the login intent pattern implemented with a consent API and client-initiated backchannel authentication. Before we have a look at the flow, let's see what actors are involved in it. Even though there is some backchannel communication going on in this pattern, the user must be present in front of a device. The user will be operating two different applications. The first one is what Open Banking describes as the third-party provider. It's a client which provides business functions to the user, and which requires access to the user's resources exposed by a bank. For example, read the user's account balance or make money transfer. The TPP client is the one which needs the user's consent to perform the needed action. The second application is the bank app. This is the application which provides an interface for authenticating the user and to take the relevant consent from them. The consent itself is managed by a consent API. This service is responsible for handling consent objects, registering new consents, updating statuses, and providing the bank app with information about consents waiting for authorization. Finally, there is the bank's authorization server, which is responsible for authenticating the user before they approve a consent. This server is the one which will eventually issue access token to the TPP client. It also issues access tokens which are needed by apps to access the consent API. Let's have a look at the steps of the flow. It begins with the user performing an action in the TPP client which needs access to the user's resources exposed by a bank API. The TPP client obtains a client credentials token at the bank's authorization server, with the scope consents. This access token allows the TPP client to register a new consent in the consent API. The TPP client registers consent data as well as the subject. In return, it gets a consent ID. This consent ID is now used by the TPP client as a prefixed scope. The TPP client starts client-initiated backchannel authentication flow with that scope in order to obtain an access token to call the bank's API. The authorization server persists relevant information about the request, like the subject and the consent ID, and, as usual in CIBA, sends back to the TPP client an authentication request ID. That request ID is used by the TPP client to poll the bank's authorization server in order to check whether the user has approved the consent. Every time the TPP client polls, the bank's authorization server calls the consent API to check the status of the given consent. If the consent is awaiting authorization, the TPP client gets back a 400 response and can poll again after the set interval. Now the user opens the bank app. The bank app authenticates the user, again with the consent scope. Once the user is authenticated, the bank app gets an access token, which can be used to call the consent API. The bank app first gets all the user's consents and presents the pending consent to the user, together with any relevant details of the consent, and asks for approval. Once the user approves the consent, the bank API calls the consent API again to change the status of the consent. When the TPP client polls now, the authorization server will get an information from the consent API that the consent was approved. The authorization server can issue an access token to the TPP client, and the TPP client can now access the bank API. Let's have a look at the whole flow again. First, the user performs an action in the TPP client which requires access to the bank's API. The TPP client obtains a client credentials token which allows it to register a new consent in the consent API. The consent ID is then used in a prefix scope during a CIBA authorization request. Once the CIBA flow is initialized, the TPP client polls the authorization server, checking the authentication status. The authorization server checks the status of the consent in the consent API every time the TPP client polls. Meanwhile, the user opens the bank app and is authenticated. The bank app then gets the user's consents and asks for approval. When the user approves a consent, the bank app calls the consent API to update the status. When the TPP client polls the authorization server again, it gets the access token, as the consent has now been approved. I will now show the logic intent pattern implemented in the Curity Identity Server. I'm using auth tools to simulate requests from the different clients used in the flow, the TPP client and the bank app. First, I need my TPP client to obtain a client credentials token with the consent scope. Once this is done, I can use that token to call the consent API. The consent API accepts data about the consent itself, information about the user, the permissions it needs, and information for how long should the consent be granted. In response, I get a consent ID. I can now copy that consent ID to use it as a scope when initializing a SIBA flow. I prefix that scope with the consent colon. I also add login hint to the request. This is the same login as the one I've provided to the consent API, and should be the same that will be used when logging into the bank app. In a real-world scenario, this would most likely be the identification number or username that the customer uses to log into their bank. Somewhere during the flow, the TPP would ask the user to enter that username. When I start the SIBA flow, I get back an authentication request ID. This ID is then used to poll the authorization server. For now, I get a pending authorization response. The next request is sent from the bank app. I run a standard auth code flow to authenticate the user and authorize the app to use the consents scope. I log in to grant the bank app an access token. The obtained access token can now be used to call the consent API and get the user's consents. The app will now present to the user pending consents and ask for approval. I will copy the ID of the consent and use it in the next request to approve it. Again, the previously obtained access token is used. The consent is now approved, so I can go back to the TPP client and poll again. This time, I get a 200 response and a set of tokens which can be used to call the bank's API. If you have any questions or comments about the logic intent pattern, don't hesitate to contact us. Thanks for watching.